Hello, this is TelecomTV reporting from IDF 2015, the Intel Developers Forum here in San Francisco in California. I'm talking with Jose De Francisco, who is Director, Cloud Marketing IP Platforms Division at Alcatel-Lucent. Jose, welcome. Thanks for talking to us. Really fascinating demo. I've just seen it off screen, as it were, before, so I'm looking forward to seeing it. But this is about NFV and the reality of NFV. Now, NFV has broken from nowhere to become enormous in just over 2 years. We've gone beyond the proof of concept stage. Everything we've been done in the labs is now getting to the point where we're getting close to commercial deployment of NFV for CSPs, operators, and so on. This is what you're being shown here. Can you tell us about it? You're part of the Intel Network Builders community. What does that mean, and what's being shown here?
So we are going to be discussing lean NFV ops, lean NFV operations. This demonstration system delivers a fully virtualized voice over LTE environment, VoLTE, and everything that we are going to show is real. Commercial grade products that we are either already deploying or delivering toward the end of the year. NFV has already gone through an experimentation cycle with a number of POCs, proof of concept projects, and this year, 2015, this is when rubber hits the road, and now we are deploying virtual network functions in real NFV environments, which we are going to demonstrate in the next couple of minutes. Now, the promise behind NFV is to deliver highly dynamic network behaviors that coupled with full programmability and control. And we need to make sure that we do that we architect that in a very lean fashion, because we would like to start to streamline and right size at any time, whether we grow scope or scale, we need to remain lean, opposed to going back to the bloated systems of the past that would throw us back to bad engineering behaviors. So we are very proud to be here at IDF 15 this year. We are members of Intel's Network Builders community, and we are working closely with Intel to deliver solutions that meet and exceed our customers' expectations. Real stuff that can be deployed as we move forward. So what you see here is a fully virtualized end-to-end VoLTE, voice over LTE environment. The virtual EPC is located here at the bottom. It's decomposed, it's a decomposed system. This is an application-driven interface. At the top, you see the IP multimedia subsystem. The two together deliver the VoLTE service, voice over LTE, over 4G networks. Now, but let me show you what we did just a couple of days ago before we came to San Francisco. I had nothing. There was nothing deployed. There was nothing to run video on. And therefore we had to start the deployment from scratch. This is something that takes more than 20 minutes. We don't have the time today, so I'm going to show you our time machine function that goes through the logs and recreates in a time-lapse version what happened when we were in the labs just last week. I'm going to use Motive Dynamic Operations, that is our OSS. It takes care of the fulfillment and assurance of the overall solution at service level. So just to make things easy, on the catalog I only have the virtual EPC, which I'm now asking for this system to get it deployed right now. Gray icons, we are placing reservations on the system, compute, storage, memory, networking. Yellow, we are already on board in the applications, provisioning and activating them. When they become green, which should happen in the next minute, they are active, ready to carry load, ready to deliver service. The ones that become blue, since I am operating in an HA, high availability environment, these are actually the mated pairs that will help me pick up the load should something happen to my primary systems. Virtual EPC, it takes 15 minutes or so. Here you guys saw it happen barely in a minute because we were recreating something that took place in the labs. That alone is already giving me broadband, mobile broadband, data access, so that I can use the 4G network for email, for video, so on and so forth. But I can do more. I can use 4G to deliver voice. To that end, I need to deploy the IMS, the IP multimedia subsystem. Once again, I go to my OSS. It shows me the application catalog. By the way, now you see some of the assurance checks. What I deployed before is functioning perfectly. And I'm going ahead, same process as before, just one command in this case, and I'm deploying a full-blown solution, creating the network, spinning up the virtual machines, onboarding the services, provisioning and activating the service. So we are going to wait just barely for a minute for this part of the deployment to finish, and as soon as that happens, we are going to switch to the runtime environment, the real environment that's executing all of these loads right now as we speak. And here you are. Now I have switched from the time machine, going through the logs, recreating the deployment that took place in the labs, to what's available right now. And when we talk about operations, things change. That's the nature of operations. So let's change the scope of this solution. Let's add more applications. So I'm using a tablet to browse through my application catalog. This is the one that we are using at the Cloud Innovation Center in the labs back in Chicago. It shows a variety of applications. I have already handpicked, for experience's sake, a few of them, but deploying any service in an NFV environment should be as easy as this. I throw it over my shoulder and it gets immediately deployed. This is now happening in real time. I'm going to do it again. So I pick another application, an antivirus, and there you have it. One more time. Here goes another application. Same process as before. The only difference is that before I was deploying full solutions, now I'm deploying one application at a time. And therefore now I have control to do whatever I like to do on a step-by-step fashion. Let me show you that. So virtual machines, available, service, instantiated, activated, so on and so forth. Now I'm going to do service function chaining. Instead of working just with the OSS, now I'm going to engage SDN, software-defined networking. This is Alcatel-Lucent's NUAS networks. So I have already picked one of the applications that I deployed. I'm going to chain it. And by the way, on the other screen, on the other side, you will see all of the UIs being refreshed as we conduct operations so that our customers can tell what solution is delivering what value. But look, the network just was created. This service is now fully usable. By the same token, I can chain another one. And again, this is happening in real time right now. And I don't need to hide in a lab to do a lot of market research and to hide in a lab for years and to come out when the market has already moved to another space, not knowing if I got it right or not. I can let the market test the applications I would like to deploy. And I am doing that as we speak. These applications are already getting acceptance in the marketplace. We see traffic running through them. This one is not, for whatever reason that I would get my marketing team to research on. But at this point of time, I wouldn't like for this zombie service to be taxing resources that I need to launch more of the applications I need to test. Therefore, I'm going to do graceful termination, which means the compute, the storage, the memory, the networking, everything that was exposed to this one service now has become freed up for the next batch of successful applications. I continue to reuse the same resources over and over, therefore I'm tapping in the NFVI, Network Functions Virtualization Infrastructure. I'm not adding more servers at this point of time, I'm not changing the hardware, I'm hardware agnostic, and yet I'm using all of the resources that I need to change the configuration and scope and scale of the system. Let's go back to changes that happen in real life. So what if we were so successful that we were concerned with becoming victims of our own success when we get so much demand and we fail to grow? So this is a load generator. I'm going to show you now Bell Labs Analytics and data that comes from the application's behavior. I'm going to crank it up. So what you see right now is this application is being successful, traffic is ramping up, we get predictive analytics telling us that if we don't do something on time, we are going to max out resources, but look, the system is already building up capacity. Same process as before, different way of operating. Early on, at the beginning of the demonstration, I was asking the system to deploy full-blown solutions. Later on, I switched to deploying one solution at a time, and I was service chaining them. Now, different operating mode, I'm letting the service just behave and react immediately and in advance to things hitting my network, like pent-up demand in this case. By the way, as I was building up capacity, I also deployed automatically a load generator, so the load has been now distributed. What if the opposite would also be true? I'm successful for a period of time, and then demand goes away. What do I do? So let's simulate that. I'm going to ask the load generator from Bell Labs to take down all of the traffic that we were creating. So now these become excess resources that I have no use for, yet they are taxing, my infrastructure. Look, I'm already conducting graceful terminations, hands off. Yeah, under this operating mode, I'm fully automated, therefore I don't need to do much more than just getting the alerts and acknowledging that this is the process I would like to follow. Our customers have the choice to do full automation or something that's also known as autonomation, which is we only run automation to a point at which we are comfortable with, and we couple human and machine intelligence to deliver the best outcome possible. In real life, we not only deploy things, grow them, degrow them, so on and so forth, failures happen. So, let me show you, I'm going to cause one of those failures on purpose. I could do something to the QoS, quality of service, which would impact network traffic, packets could get lost, or I could create a cloud problem. I'm going to corrupt a virtual machine. Again, I'm going to do it on purpose. Or maybe a hacker is doing that. Whichever the problem, we are operating in an HA environment, high availability. So we are going to make sure, as we are, that there is no disruption to the end user service. As a matter of fact, we have 2 phones in this demonstration that are running continuously a 4G video call, and no matter what we do, operationally speaking, in the background, the end user experience will never be impacted. The end user will never be able to tell that we were reconfiguring and restoring systems in the background. Now, what I'm going to show you now is the only part of the demonstration that is not a product, but research findings from Bell Labs. And we are going to talk about smart placement. We are talking like a certain level of awareness that enables us to take full advantage of the efficiencies that we discussed before. Much of what I'm going to discuss is already in our products, but not in the presentation, in the rendering that I'm going to share with you right now. And this is what we call the recommendations engine for smart placement. So I was in a duplex HA high availability environment. I took down one of my systems, the other one picked up the load, I was okay, the service is running, but now I have to restore HA. I need my other system to be recreated. So where do I do that? The smart placement recommendations engine is actually telling me that after doing some checks across cloud resources, network resources, application requirements, SLA compliance, and some other factors, I should go and work in the Naperville data center. I might or I might not trust that. Therefore, I'm going to ask for the next best recommendation, which is asking me to do that at the London cloud node, though I already see that that is a suboptimal implementation. So again, I'm coupling machine learning, I'm coupling analytics, machine intelligence with the expertise that comes from the operations team, the human being, that is. Now, if I decided to, and I can run more of these recommendations, I can actually get analytics that support the recommendation, that tell me if things look green, if there are any problems in terms of assurance at service level, and this comes from all of the solutions that are involved in this demonstration. The OSS, that's multi-dynamic operations, MANO management and orchestration, that's Cloud WAN, SDN, NOASH networks, as well as the VEPC, VIMS, all of these forming part of the Alcatel-Lucent NFV portfolio. Now, what if I don't like to execute this? Well, then I just stand down by pressing the red button. Or what if I needed more time to do root cause analysis, to get more of these correlated metrics that I was showing a minute ago? Well, then I put the system on standby, which means I'm making reservations on the compute, the storage, networking, and whatever other resources I need, so that I can take the time, and when I make my decision, those resources will be there available to execute. Now, that also means that those resources are not available to other applications while I'm taking my time to make that decision. But if I accept, what happens if I accept? Well, this could be a one-time event, therefore I will execute the recommendation. I'm going back to the one that's optimal. or if I feel that this should be mechanized, what I do is I make it become a policy by clicking another button. Therefore, next time that an event of this kind comes up, the system will take care of business and I will get the report and all of the logs and everything that monitoring is about. Now, let me accept and let me show you what happens now. So, Cloudband, our MANO, Management and Orchestration System, is working with OpenStack. That's our Virtual Infrastructure Manager, VMI. And we are also from the OpenStack community, we're using Mistral. And here is the workflow that we are executing live right now to restore the HA environment that I was discussing before. Once again, this is no science project, no POC, no more experimentation. This is a real system, end-to-end system, doing what's supposed to do right now, this minute. I will let it run, and I will show you one more thing. So this is not just about the technology for the sake of technology. Innovation calls for purposely driven solutions that deliver clear value. It could be top line, bottom line, it could be about CapEx or OpEx reductions. It could also be about generating new business opportunities for the network operator. So everything that you have seen up to this point is encapsulated in this circle. These other logos that you see around are actually simulating a universe of customers, namely MVNOs, enterprises, so on and so forth, network operator customers, that is. So we are going to pick one of these so that you can see that this company, this network operator customer, is using the network operator resources to create its own chains, its own networks, to deploy as many applications as they need from a system that's actually fully automated and delivered as self-service to that customer base. So our customers like it because they don't have to incur the time and the cost of babysitting their own customers. Their own customers love it because they are fully empowered as this becomes self-service and they can manage their own operations. Last but not least, at all times, I was running on this infrastructure. This is our lab back in Chicago. Commercial off the shelf, going back to cloud fundamentals, completely hardware agnostic. We work at the application and orchestration layers. And I was reusing all of these resources over and over in real time to do all of the configuration changes that we just experienced. There is one more thing, okay? So we are going to create a catastrophic network failure right now. Let's see how that plays out. So this is what we call the best testing machine ever. On my right side, you see a retro-looking Galileo-powered, Intel Galileo-powered whack-a-mole machine. And as you will see, we'll be using it to create a chain reaction that will deliver actually a catastrophic network event. That's a network failure. And yet, it's connected to our live system. So for real, what's going to happen is that our system will self-heal and recover gracefully from whatever damage you are going to cause today.
I've always wanted to bring about a catastrophic network failure, so I'm going to give it a go.
Be my guest.
All right. Hey!
So good job, you created a major catastrophic network failure. Congratulations, you are hired.
Thanks, Jose, very much.
You're welcome.
Enjoyed it.
Thank you. My pleasure.